Hello, everyone. This is Arthur Moores, and welcome to Relations, Domain, Range, and Functions. Okay, so let's take a look at a few definitions. Relation, that's a set of ordered pairs. The domain is the set of first elements from each ordered pair, which is usually your x coordinates. The range is a set of second elements from each ordered pair, which is usually the y coordinates. A relation in which each first element is paired with exactly one second element is a function. Okay? So let's take a look at a few examples here. So let's say we have a set of ordered pair of 2, -6, -1, -10, 5, -2, and 4, -6. Well, your domain is just the first number in each ordered pair, the set of first numbers from each ordered pair. So 2, -1, 5, and 4. The range is the second element in each ordered pair. So -6, -10, -2, and there's no need to write -6 again. Now, the question was, is this a function? Okay, let's look at each x element. 2 is paired with -6. That's the only number that 2 is paired with. -1 is paired with -10. That's the only number that -1 is paired with. 5 is paired with -2. That's the only number that 5 is paired with. 4 is paired to -6. That's the only number that 4 is paired with. So yes, this is a function. Now you can have two different x elements like 2 and 4 paired with the same y element, but each x element has to be paired with exactly one y. Okay, the second example here, we have 5, 1, 2, -8, 5, 9, and 3, 8. So my domain, 5, 2, 5 again, and 3. Now, with me seeing that 5 listed 2 times in my domain, that tells me that this is not going to be a function because 5 is paired with 1, and 5 is also paired with 9. So since 5 is paired with 2 different y elements, this is not a function. My range, 1, -8, 9, and 8. This is not a function because my 5 is paired with 2 different y numbers. Okay, let's look at this mapping here. Let's find our domain and our range, and let's state whether this is a function or not. So in my input, which is the same thing as my first or x elements, I have -3, 0, and 5. So that's my domain. -3, 0, and 5. Then in my output, when I put in -3, I get out 10. When I put in 0, I get out -2 and 7. And when I put in 5, I get out 0. So my range or my output is -2, 0, 7, and 10. So I can clearly see that 0 is paired with 2 different y elements or 2 different outputs. Therefore, this is not a function. It's not a function. Okay? We can also determine whether graphs are functions by using the vertical line test. The vertical line test states that if we can draw a vertical line anywhere through the graph, to where it will touch more than one point at any given time, then the graph is not a function. If we can draw a vertical line anywhere through the graph where it will touch more than one point at any given time, then the graph is not a function. Okay, so let's look at these two graphs here. I have a straight line, diagonal line here, and I have a circle. Well, it does not matter where I draw a vertical line through this diagonal line. It will only touch one point at any given time. So yes, this is a function. However, if I use a vertical line test on this graph to the right, you can see that if I draw a vertical line there, it will touch 2 points on that graph. So no, this is not a function. So the vertical line test again says that if you can draw a vertical line anywhere on the graph and it touches more than 1 point on that graph, then it is not a function. So let's look at one more example using the vertical line test to determine whether a graph is a function. So here I have this U-shaped figure, and then I have this green curve-shaped figure. So the whole thing is my graph. So you can clearly see that if I draw a vertical line through here, it's going to touch more than 1 point at any given time. So therefore, no, this is not a function. Okay, I hope you found this video to be helpful. Thanks.